How's it going, YouTube? We've been learning all kinds of different relationships among our trigonometric functions, so I thought a good way to put all those together would be to solve a few right triangles. What I mean by solving right triangles, I mean problems like this, where we have essentially a right triangle because one side's been marked out as 90 degrees, but we're missing the value of some of the sides and maybe even the values of some of the angles. We can solve problems like this by essentially looking at our connections with those trigonometric functions and fill in all of the missing pieces. We'll see this as we move on to my first example. So in this first one, I'm dealing with a nice right triangle. There's my 90 degrees, but I'm missing a leg of that right triangle. I'm missing the hypotenuse, and I'm not even really sure what that angle is in the upper corner there. No problem though, we can find all of these really by looking at some of the relationships we know so far. Some of the handy ones will be, of course, our basic trigonometric functions, but also the Pythagorean theorem comes into play if we know, say, two legs. We can always find the third side, or just knowing that all of the angles in a triangle add up to 180 degrees. So there's all kinds of different ways you can approach this problem. Let's see where we can begin. Since I know that this angle down here is 38, and I'm dealing with a 90 degree in that corner, I can find the missing angle by simply taking the total, 180 degrees, and subtracting out the angles that I already know about. So I have my 38 degrees minus the 90 degrees. This shows me that what I have left for the upper angle here, it has to be 52 degrees. All right, good start. So now we have every single angle that we need. Moving on, let's see if we can figure out one of these sides. If I want to figure out a side, you essentially just have to use one of your trigonometric functions as long as that particular trigonometric function uses a known side. So what I'm going to do is I'm going to use, let's say, cosine of 38 degrees. So I'm looking at that angle right here. And cosine is the adjacent side divided by the hypotenuse. Now you can really see why it's important to use one of the known sides, because I'm hoping that the unknown will be something that I solve for. If I tried to use something like sine, I'd end up taking b over c, and I'd have too many unknowns. I couldn't really move forward with that. All right, so let's see what we can do with this. So I want to end up solving for c, so let's go ahead and multiply it by both sides. And then to get c all by itself, we'll go ahead and divide both sides by cosine of 38. Not bad. So this says that c is equal to 47 divided by the cosine of 38 degrees. Now if we punch this into our calculator, we'll get around 59.64. All right, so we know another side, 59.64. Now at this point we have some options. Now that I know two sides of this right triangle, I could use the Pythagorean theorem to go ahead and find that missing side b. Of course, since we also know one of the sides, I could use another trigonometric formula to go ahead and find the missing side of b as well. Both of those are perfectly valid methods. I'm going to go ahead and use another trigonometric function just so we can see how that process will play out again. So now I'm going to deal with tangent of 38 degrees. So I'm still using the same angle here. Tangent is the opposite side over the adjacent side. So now I can end up solving this for b, which is simply 47 multiplied by tangent of 38 degrees. Again, we could take this value, plug it into our calculator, and when you do, you get around 36.72. And that would give us all of our sides. So 36.72. Now, I am rounding some of my values that I'm getting out of my calculator, so depending on what your work says, you may need to round it to more decimal places. Also, since these numbers are rounded, if you were to double check them using something like the Pythagorean theorem, they may be off by just a little bit, but looks like we got our values and we can move on to yet another example. In this next triangle, I have two sides of my right triangle, but I have no idea what these two angles are. In a situation like this, I really like to use tangent to help me figure out some of these missing angles. So I'm going to say tangent of, I guess I better mark this guy, let's call it theta. Tangent of theta is equal to 77 divided by 40. Now, as you can see, it's going to be really tough to figure out what this angle is because I'm essentially saying what is the tangent of that angle. But if you have a calculator, you can figure out that angle by using the arctangent on both sides. Let's go ahead and grab that calculator. So I'm going to use this and use my second tangent. That'll bring up the arctangent. You can see because it has a little -1 there. Now type in 77 divided by 40. Now what this will do is it'll actually give me the angle that I'm looking for. So this is around 55. If you want this in degrees, minutes, and seconds, you can go to second angle, convert that answer to degrees, minutes, and seconds. So it's around 62 degrees. Let's round it to 33 minutes. All right, not bad. So now we actually have two angles in our right triangle. I have the 90 and I have the 62.55. Now we can use the fact that they all add up to 180 to find all of my angles. So 180 minus 90 minus this one we just found, 62.55. So what do we have left? We'd have 27.45 degrees. All right, so I have one angle, two angles. Still need that missing side. You know, I think this is a good way that we can actually throw in the Pythagorean theorem, so let's go ahead and do that. So 40, one leg, squared, plus 77 squared equals c squared. Combining these over here, I'll end up with 7,529 equals c squared. Then I can take the square root of both sides. And it looks like this turns out just to be around 86.77. And that's our value for c, or at least something really, really close to it. I did round that one just a little bit. So there's no good reason why I used the Pythagorean theorem to find it that way. I could have also used one of my trigonometric functions and it would have given me the same value, as long as I picked a trigonometric function that related a known side with that unknown hypotenuse. So feel free to see other ways that you can go ahead and approach these same problems and use them to check yourself and make sure you're getting the right answer either way. If you'd like to see some more videos, please visit MySecretMathTutor.com.